Myself, Sourabh Sharma, student of BTech 4th year at Faculty of Engineering and Technology, University of Lucknow. Today, I am going to my presentation, seminar presentation on amphibious house. Let's begin on first slides. Content. Now, first point, introduction. Second point, material used in this construction. Third point, how do amphibious house work? Fourth point, how are amphibious house designed? And stability and features, case study, disadvantage, conclusions, and reference. Introduction. An amphibious house is a building at rest on the ground, but whenever a flood occurs, the entire building rises in its dock, where it floats by the flood water. It is a floating structure and makes it resistant to flood and earthquake. A structure which can survive on land and also against heavy floods, where it rises on top level of the flood by providing sample safety to the life. The only material which make outweigh to enlistment of the structure can be done only on EPS. Now, material is in this construction EPS, expanded polystyrene. In figure, this show EPS structure. It is a polystyrene is a synthetic aromatic polymer made from the monomer styrene. A liquid petrochemical polystyrene is a clear, hard and brittle. Density 1.05 gram per centimeter cube. Melting point 240 degrees centigrade. Formula C8H8. Properties of EPS: retention of vitamin C, resistance to humidity, compressive resistance, shock absorption, thermal insulations, low weight and chemical resistance. Hollow concrete. In amphibious house, we use hollow concrete because they can be made much larger than solid brick, and if lightweight aggregate is used can be very light without for fighting much of their load bearing capacity. They can be made to any shape and size and remain dimensionally stable. They require for less mortar than solid brick because of cavities and less proportions of joints due to large size, and construction of wall is easier and quicker. The cavities can be filled with reinforcement and concrete achieving high earthquake resistance. How to amphibious house work? Amphibious house work on the basis of Archimedes principle. The principle used in the Archimedes principle, which states that the upward buoyant force that is exerted on the body immersed in the fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body. Based on the principle, a hollow concrete box is created which open on top of on which the upper structure is constructed in a similar fashion as traditional building. How are amphibious house design? A bounce raft or hollow fox foundation, also known as floating foundation, is used in this construction on soft and weak soil. Traditional foundations are therefore not required. The position on the floating home is permanently, while it can flexibly follow vertical variation in water level. The base of floating home consists of a floating mechanism that secures the building buoyancy. The amphibious design allows the floor level to be the set less than 1 meter above the ground level instead of 2 meter. Had the house been static, if we can see this figure, the first figure so resting on position and second the float event. Stability and feature. A tilt position of 4 degrees is acceptable as long as the distance to the adjacent house remain at least 3 meters. The mooring poles are positions in an angle, this giving the greatest stability. A wooden construction on the top of concrete gives a low certain center of gravity. A house that is top heavy would be the much more sensitive to storm and heavy weather. For the same reason, it is advisable to put the bathroom on the lowest floor and the kitchen on the entrance level. These houses are fixed to the vertical guiding poles. With the help of this house can reach up to the height maximum of 18 feet. The house are efficient even in the shallow depth of water. The structures serve as flood resilient construction. Now, case study. Case study on this project is Bucks Waterbird, a floating building community in Amsterdam. Architect Marlis Romer gave the project base house. In low-lying country like Holland, planning was focused on the separating and maintaining the division between land and water by reclaiming land from the sea by building dams and the heightened lake. Problem became further acute in the last decade due to the global warming, leading to rising water coupled with several unusual dry summers. The sea level is said to have risen by 20 centimeters in the last century and is expected to rise by three times that amount in the 21st century. Program water, but according to final urban design, 165 floating house, 55 project house in three times, 13 Vancouver solo resident space 156 square meters, 24 Sydney Dew 107 square meter owner occupied, 18 settle 100 square meter, 110 private plots, 38 built rest with flow, 7 deck house 128 meters square, 3 pile dwelling 112 square meters, 30 office and car park also intended for residence of the floating house. If you can see this figure, the plan of waterbird floating house. The building involved water but east width 7 meters, length 10 meters, height above water 7.5 meter, depth underwater 1.5 meter, third story 50% of the maximum surface, minimum of 20% of the plot must depend open water so cannot be used for the garden or terrace. Disadvantage of this seminar project, EPS required an additional and polyurea coating for the incrementation of resistance for exposure to surrounding which is costly. A minimum depth of 1 meter be considered for effective placing surface. Conclusion: EPS is a good example of efficient use of natural resource. It is 98% here. The manufacturing and use of the EPS does not generate any risk to health or to the environment. EPS does not damage the ozone layer since it does not use CFC or HCHC in the manufacturing process. Fungi and bacteria cannot easily grow on EPS. Reference of the project. Thank you.